Hey guys, welcome to the review of Chapter 3, Sections 1 and 2 describing central tendency and measures of variation. I guess before we get started, I don't recall if I've mentioned this or not in a prior video, but I think that the way that you guys should handle these reviews, which is different than the lectures, is for the reviews, do as much of it as you can on your own, I'd say, and then watch the video. Because I don't want me kind of solving these problems to be a crutch, but I think it's a good learning tool as you go through the PowerPoint slides as I describe things during the lectures for you to kind of follow along and do the problems as I do them. But I think for the review, it makes the most sense for you to kind of go as far as you can until you get stuck. Hopefully you can do the whole thing and then watch me solve it and then kind of fill in the blanks there, and then answer or then ask any questions that you have, in the discussion forum or email me or whatever. But yeah, I just think that it's probably best for you to try to solve these on your own beforehand and kind of go until you break it and then fix it. That's kind of always my philosophy is try it on your own until you can't anymore, and then find out what you're missing. So okay guys, so yeah, we're going to start in on the review. So I guess if you haven't completed it yet, pause the video, go do as much as you can, come back in an hour, and I'll be here and I'll be solving this stuff for you. So alright, here we go. So 5a, calculate mean, median, and mode for the following population of numbers. So I guess I will go ahead and So 5a, calculate mean, median, and mode for the following population of numbers. Now this is 3b from page 106 in case you're wondering. So I'm going to do the easy ones first. Mode is just going to be the value that is occurs most frequent. We can just look at the data and we can see that it's 90. So MO for mode, 90. It's going to be the one that occurs the most. And then median, we just are going to be chopping off different pieces of the data, the highest and lowest pieces of data, until we get to the middle. So how many pieces of data do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median is actually going to exist in here because it's an odd number. So I'll just go ahead and chop off the highest here, and then the lowest, the next highest, and then the next lowest, and the next highest, and the next lowest. 110, 90, so it looks like 100 is going to be our median. Fair enough? Okay, so then now it's just our job to calculate the mean. And the mean is, and we're considering this a population, so the mean, the formula is going to be mu is equal to the summation from I equal 1 to big N of, is it x sub I all over N. Let's make sure that that formula is right. That formula is right. Okay. So in our case, that's going to be the summation from I equal 1 through 9. So that's the number of pieces of data of x sub I all over 9. And that's going to be 110 plus 120 plus 70 plus 90 plus 90 plus 100 plus 80 plus 130 plus 140 is equal to, all over 9, which that is equal to 930 over 9, which is 103.3 repeating. So that is our mu. Okay, and now we're going to move on to 5b. So calculate the range, variance, and standard deviation. So the range is the easy one. So range we just know as the max minus the min. So the max value up here is 140. The min value is 70. So we have a range equal to 70. And try to keep as much of that in picture as I can. And I guess I'll set this equation up for you, and then we'll go to Excel to actually calculate it, just because it'll get pretty, I guess, labor intensive. So we have sigma squared because we're working with a population, and that is equal to the sum from I equal 1 all the way to big N of x sub I, so each piece of data, minus the mu minus the mean, that squared, that difference squared, all over big N. And remember, it's not n minus 1 because we still are working with a population here. If it was a sample, it would be n minus 1, little n minus 1. Right? So this is the summation of I equal 1 to 9 of x sub I minus 103.3 repeating all over 9. And that's going to be, I'll just start it, and we'll say 110 minus 103.3 squared plus 120 minus 103.3. So of course repeating, squared. We just all the way to 140 minus 103.3 squared. And then that whole thing would be over 9. Okay, so that's going to be the general formula. So this is just 110 minus 103.3 repeating squared plus 120 minus 103.3 repeating squared plus 70 minus 103 plus 9, you know, that. So you go each number, so each x sub I, each data point, minus the mean, square that difference, add those up, and divide it by n, divided by 9. Okay, so we'll go over to Excel, and I'll show you guys how to do that in Excel, kind of like we did in the lecture. So, number 5 data. So it looks like I've already done some of this. So here's our data. Okay, and looks like I said equals sum of that. We get 930. Oh, so I did part A in here. So we get 930 divided by the count, or the n, and that gives us the mean. Equals. And then it looks like I also, so I did that as kind of a hand calculation. Then I just used the function to come up with the mean. So I said equals average of that range. Excuse me. So we'll go ahead and do this again. Let me steal these headers. Again, so we have xi minus mu and xi minus mu squared. So we say equals this piece of data minus the mean, and we want to hold that cell because we want to use that everywhere. Okay. Sorry, I heard in my last video that I'm like banging on the keyboard. I'm going to try not to do that, but when I get excited here, that's kind of what happens sometimes. Okay. And this is just a flat out really loud keyboard, so that's my bad. Okay, so we took the difference between the x sub I and the mean, and this is what this column is. We square those differences. We add those up. Okay, 4,400 exactly. And we divide that by n. So that's the sum. So say that divided by n. And this is going to be our variance. And then if we want the standard deviation, we'd say the square root of that. Square root of that. So okay, so then here's what we'll do to check our work. We'll just use the functions. We'll say variance of population. Boom, that's it. That's exactly right. And then we expect standard deviation to also be exactly right, which it is. And so then we'll go in and we'll look at the range, variance, and standard deviation done in Megastat. So you see we have add-ins open up here. We go to Megastat, descriptive statistics, find the range. Find the range. And not this, not this, not this. I guess we do want mean. We can. And then population, variance, and standard deviation. And then I guess we want range too. Apparently, to just check all of our work. Okay, so we run the output. Mean was 103.333 repeating. That was right. 488.89 and 22.11. Let's see. 488.89, 22.11. So we're dead on. So we got it right. Okay, now we're going to switch to number 6 here in the worksheet. Okay, so number 6. In order to control costs, a company wishes to study the amount of money its sales force spends entertaining clients. The following is a random sample of 6 entertainment expenses, dinner costs for 4 people, from expense reports submitted by members of the sales force. This is 322 on page 116. First thing I'll say that I'm going to set up this problem, like writing it out, but I'm going to do all my calculations on Excel just because it'll save time. So yeah, that's the first thing. And yeah, so that's that. So let's get into the problem. And I would say the first thing that I would note in this whole thing is not the data set, it's the fact that it says sample. Right, so we automatically know we're working with a sample and we are not working with a population. Okay? So, population. Nope. And yeah, so this is how we'll start. So, I guess one thing that we can calculate on this sheet is going to be range. Range is always the real easy one. So range is just going to be that max minus the min, and that's going to be 157 minus 109, and that is equal to 48, I believe. Yeah, everything else, let's just do in Excel. All right, so I'll flip over to Excel. We've got 157, 132, 109, 145, 125, and 139. So that's right. So the first thing we want to calculate is range. So we'll just start over here. We'll say range, and we'll find out what the max of the data is. I hopefully you guys appreciate this, because I feel like a lot of this Excel stuff is worthwhile, especially if you haven't seen it before. So it's fairly comfortable for me to do stuff like this, and I just hope that it helps you guys too, because I think it's nice to have this skill set a little bit. So yeah, 157 minus 109. So we'll say that minus that is 48. So that's what we're going to say our range is. And home, and let's just put a box around that. Perfect. Okay, so the next thing that we want to do is X bar. So x bar or mean, I guess, or sample mean, I should say. And that is, I'm just going to be average of this, 134.5. And so that's using that function, but we could also say, we could also just sum up those values and then divide that by the number of those values. So we'd say sum divided by, so sum of that area divided by count of that area. So that's going to be, that's also 135.5. So we know that we did it right. We know that the Excel function is in fact working properly. So good. So that's good. So we have x bar. Now we want to have s squared and s. So we'll go ahead and do it our like handwritten way that we've done in the past. And we'll just minus x bar from all of the x sub i's. So this minus x bar. And we want to hold that, so we hit F4, and that holds it, puts the dollar signs on there. Okay, we run that down there. Oh, that sort of thing that I'm doing, so you can drag it down with, you hold down Shift and then the arrow keys up and down, and that'll hold that. And then you hit Control D, and that pulls the formula all the way down. Okay. Feel free to ask me any of those questions that, you know, they're fun little shortcuts, and yeah, that's that. So, okay, now we square that. So we just have that cell to the second power. Okay. We add those up. So sum that column. And we're going to divide that sum, because this is a sample, not by n, but by n minus 1. So we're going to divide it by the count of this minus 1. And divide that out. This divided by this. Okay, so that's what we're going to call our, I guess, our hand calc variance. And then let's see if, then we take the square root to get the standard deviation. So that's that. Now let's see if Excel has the same calculation. We'll just say var.s, open parenthesis of our data here. Good, looks good. Standard dev.s. So that's that. Great. So we're perfect there. So we've completed A, it looks like, right? So x bar, s squared, s, and range. So now B, assuming that the distribution of entertainment expenses is approximately normally distributed, calculate estimates of tolerance intervals containing 68.26%, 95.44%, 99.73% of all entertainment expenses by Salesforce. Okay, so what this is asking us to do, I'm just going to scroll down just a little bit. B, goodness, this pen. B is, we'll say, referring to empirical rule. So the 68%, let's say circa, or, you know, around 95, we'll just say 99. This is going to be x bar plus or minus 1 standard deviation. This is going to be x bar plus or minus 2 standard deviations, and then this is going to be x bar plus or minus 3 standard deviations. That was from our empirical rule. So this is all we're having to calculate. So we're going to calculate x bar, then we're going to add a standard deviation to it, and then subtract a standard deviation to it, or from it. and that's what we're going to do to get the 68%. Then we're going to add 2 standard deviations to X bar and subtract 2 standard deviations from X bar to get the 95% tolerance interval, and then similarly for 3 standard deviations for the 99.73. So now that we have our standard deviation, so we have all of this information on this sheet, so we have an X bar. So our X bar is 134.5, so we're going to just say 68. We'll say 68% TI for tolerance interval, 95% TI, and 99.73% TI. Okay. Or we'll say lower bound and upper bound, and then this is the lower bound is going to be the mean, and I'll hold on to that by hitting F4 minus just 1 standard deviation. So we'll go find the standard deviation. Either one of these will work, and that's the lower bound. The upper bound is going to be, so actually I'm going to hold on to both of these cells. So highlight that, hit F4, and you hold on to it. And then I'm going to hit Control R, which pulls the same formula into the next cell. But instead of minusing it off for the upper bound, we're going to be adding it. Okay, so lower bound, upper bound. And then this is going to be 2 standard deviations, and this is going to be 3 standard deviations. So I'm actually just going to drag this. I'll drag both of these down. So drag them both down. Now they're the same thing still. And then we can just say times 2, times 2, times 3, and times 3. And the only reason that works so cleanly with the formulas is that the order of operations, we know that this multiplication symbol is only going to touch that. So like these get grouped together. You don't actually have to put parentheses around it. So this is the lower bound, the 68% tolerance interval, and essentially that's where we can expect 68% of the data to fall in general. This is where we can expect 95% of the data to fall in general. This is where we can expect almost 100%, but 99.73% of the data to fall in general, in between 84.59 and 184.40. Okay. So we did that, and then it says, if a member of the sales force submits an entertainment expense dinner cost of $190, should this expense be considered unusually high and possibly worthy of an investigation by the company? Explain your answer. So this is kind of a question of this empirical rule and of outliers. So it's basically saying, like, is this going to be an outlier on the top end? And if so, like, should that be alarming to us? Maybe is there something else that the money's being spent on, something else that's going on? So we're using statistics to kind of investigate here. So we say 100. So we just keep in our memory bank $190. So we go back and look here. $190 is above the upper bound of the 99.73% tolerance interval. So remember what I said when we were talking about the empirical rule, or we were talking about the empirical rule and outliers. As a general rule of thumb, you can consider something an outlier if it's above or below 3 standard deviations about the mean. This 99.73% tolerance interval is that range of 3 standard deviations about the mean. And that 190 expense falls above that range, above the 3 standard deviation range. So that is something that we could consider an outlier and worthy of further investigation. So that would be our conclusion. And we would explain that by saying $190 is, in fact, outside of the range, the acceptable 3 standard deviation range. And so therefore we think that it is an outlier and then is worthy of I guess, further investigation. So that was D. And now it's saying compute and interpret the z-score for each of the 6 entertainment expenses. So z-score is just the difference between x and the mean divided by the standard deviation. So it's essentially you're calculating how many standard deviations is this x sub I away from the mean. So we can do this down here. So we'll just copy these x sub i's. We'll put them here, and I guess we'll do the difference between x bar okay, so that's the exact same thing, and then we would divide this by the standard deviation. So z-scores. Uh-oh. That's what you get when you don't lock in the cell. Uh-oh. Jeez, what is going on? There. There we are. So the way that we would interpret this, so these are all the z-scores for the associated pieces of data. So all these x sub i's, this is their z-scores. So 157 is 1.35. This is how we would interpret this. 157, that data point, is 1.35 yada 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 number of standard deviations. So it's 1.35 standard deviations above the mean. So that's how far away from the mean it is in terms of standard deviations. Not absolutely. Absolutely, in terms of, I guess, dollars in this case, it's $22.50 above the mean. But in terms of standard deviations, it's 1.35 standard deviations. And then we can kind of like look here and just see what the rest of these are. Again, you just need to know how to calculate this and kind of need to know the basic idea of what it means. And we'll get into its uses much later in the course in Chapter 6. Then lastly, calculate the coefficient of variation. And that is just what the percentage of the mean that the standard deviation is. So if you remember, let's look in here, find coefficient of variation. That's just going to be the standard deviation over the mean times 100. So the standard deviation is relative size to the mean. So we'll just say coefficient of variation. That's just going to be the standard deviation divided by the mean times 100. So 12. So like we could say this the way that you'd interpret this is the standard deviation is 12% the size of the mean. And that's that. I believe that is it, right? So E, calculate the coefficient of variation. That's that, guys. So please let me know again if you have questions. Put them in the discussion. Write them an email, ask a peer, anything like that. Definitely ready and willing to help you guys out on this material. Hopefully I explained myself well. If not, give me that feedback. But yeah, let me know any questions that you have and I'll be happy to answer them. And yeah, until next time, this content should drop on Tuesday. Yeah. Okay, well, yeah. All right, Matt, cut that and then edit that and go. All right, thanks so much, guys. Okay, cut that again. Cut that, and then we'll start at 37. No, we'll just start at 38. All right, that should wrap it, guys. So if you guys have any questions on the material, were confused by something, let me know in the discussion forums. Send me an email, anything like that. But I definitely want to answer your questions. I would love to field any questions that you guys have. So till next time, I guess Chapter 4 materials will be dropping next Tuesday. So Tuesday